Welcome back to our STL journey. Today marks day 15 and we are diving into an essential part of the STL, the set container. Sets are perfect when your goal is to manage collections of unique values and you want either fast access or sorted ordering. Throughout today's session, we will explore the two major variants, the ordered set and the unordered set. You will learn how they work, when to use which, and how to apply them in practical programming situations. By the end of this lesson, you will have a clear understanding of how both set and unordered set work. We will cover syntax, internal implementations, operations like insertion, deletion, and searching, and the performance characteristics that differentiate them. You will also write some code, analyze time complexities, and try out coding exercises that simulate real world use cases. The goal is to help you make an informed decision about which type of set to use depending on your needs. A set in STL is a container that stores only unique elements. That's the key idea. If you try to insert a duplicate, it will be silently rejected. The main use of a set is when you want to filter out duplicates, search efficiently, or maintain a sorted structure. There are two kinds, the ordered set, which automatically keeps its elements in sorted order using a red flag tree, and the unordered set, which uses a hash table and provides constant time average access. We will be focusing on both in this session. Let's start with set, the ordered version. This is implemented internally as a red flag tree, a type of self-balancing binary tree. That means elements are always kept in sorted order and all operations insert, erase, and search run in log n time. You can think of set as a sorted list that does not allow duplicates and allows fast lookup. It's best when ordering matters, like when building a leaderboard or sorting a set of names automatically. Here we see some operations for std::: set. First, we declare a set of integers. When inserting values, any duplicates are silently ignored. Try inserting 10 twice and you will see it only appears once. Searching is done using the find function, which returns an iterator. If it matches the end iterator, the element wasn't found. Deleting is as simple as passing the value to the erase function. All of these operations are fast and reliable, and due to the tree structure, elements are automatically ordered. Now let's shift our focus to unordered sets. This container has the same property of uniqueness, but it's not ordered. Internally, it uses a hash table, which gives us average case of week of 1 performance for insertions, deletions, and lookups. However, since it uses hashing, the elements do not maintain any specific order. It's great when you care about speed and not about ordering. For example, checking if a user has already logged in or if a word has already been processed in a large text. In this example, we create an unordered set of strings and insert several values, including a duplicate. Notice how Apple only appears once. We can use find to search for specific entries. The lack of order might look odd at first, but the performance gains are significant. This makes unordered set an ideal choice when you are dealing with large data and just need fast, reliable lookups like checking if a number has already appeared in a string. This table helps summarize the core differences. In terms of internal structure, set uses a balanced tree while unordered set uses a hash table. That means set provides log n time complexity and unordered set gives constant on average. The trade-off is that set maintains order while unordered set does not. Use set when order matters or when you need predictable traversal. Use unordered set when you just care about speed and don't need ordering. Both reject duplicates, but the underlying behavior is quite different. When should you use sets in real applications? Use set for leaderboards, ranking systems, event timelines, or anywhere you need sorted unique elements. On the other hand, use unordered set for fast filtering, checking presence of elements, or removing duplicates from large datasets. For instance, if you are analyzing user activity logs and want to know how many unique users visited a page, unordered set is the way to go. Here's a quick practical task. Suppose you have a vector with repeated integers. How do you remove duplicates? Simply pass the vector elements into a set using an iterator range. This instantly filters out all duplicates. If you care about performance, use unordered set. If you want the results in sorted order, go for set. You can even convert the set back to a vector if you need array style access later. This next exercise simulates a real-world use case, text analytics. Given a paragraph of text, you want to count the number of unique words. Step 1. Break the text into words using a string stream. Insert each word into an unordered set. Return the size of the set. This simple pattern powers everything from spam filters to keyword extractors. Just try it out. Let's run a quick performance comparison. We generate a large list of random numbers and measure the time taken to insert and search in both set and unordered set. You will usually find that unordered set is significantly faster, except in rare cases where hash collisions degrade its performance. Meanwhile, set offers more consistent behavior and predictable iteration. These benchmarks help you decide which container to use based on context. Here are some key tips. First, once an element is inserted into a set, you cannot modify it directly, because doing so might break the internal ordering or hashing. You will need to remove and reinsert. Second, if you use custom data types in an unordered set, you must define a custom hashed function. Lastly, don't assume one is always better than the other. Profile and choose based on your application's need. Time to get hands-on. Here are some practice problems for you. Remove duplicates from an array using a set. Count distinct elements in multiple arrays. Check if two strings have the same set of characters. Find the intersection of two arrays using sets. These problems will give you strong muscle memory with set containers. Try them on LeetCode, HackerRank, or Codeforces. On day 16, we are going to level up. We will look at multi-sets which allow duplicate values. They are great when you want to count the frequency of elements while keeping them sorted. We will also compare them to sets and see where each fits best. See you in the next session where we go one level deeper in mastering STL containers.